Hi there. So we're going to go over the formation of urine. Here is my horribly done drawing. This is our nephron. So here we have our renal corpuscle, which are our glomerulus. This is going to be our proximal convoluted tubule, or PCT. This is our nephron loop here. And then we have our distal convoluted tubule here, DCT, and then our collecting duct. This is supposed to show more nephrons excreting their waste into the collecting duct, because collecting duct isn't specific to one nephron. It collects waste from multiple nephrons. So basically, urine formation has 4 steps. Our first step is our glomerular filtration. That's going to be over here in our renal corpuscle. And then we have our tubular reabsorption and our tubular secretion. That's going to occur from our PCT on. And then the last step is our water conservation. Water conservation occurs throughout the entire tubular area, but primarily in the collecting duct. So first what happens is, so this is our glomerulus. We have our afferent arteriole going in with a wide diameter, and our efferent arteriole coming out with a narrow diameter. That's important because that creates pressure. There's a lot of blood coming in, but it's not allowed to come out as much, and that's what sort of helps drive the plasma out of the glomerulus. Remember, the glomerulus is just a bunch of capillaries. So the plasma is sort of forced out of the capillaries and into the capsular space. It passes through filtration membrane, which has pores or fenestrations, slits, and then the shared basement membrane that it goes through. So pretty much in here, our urine is not technically called urine yet. It is called filtrate. And it's essentially the same composition as plasma. So you've got your water, your ions, your vitamins, your amino acids, your fatty acids. And it's technically, if you were to eliminate it, you'd be getting rid of 150 liters per day for women. And for men, I believe it's 180. So what happens is, once you leave your renal corpuscle, most of it is reabsorbed, because you really only get rid of 1 to 2 liters per day. So that's what's going on in our glomerulus area. Once you get to the proximal convoluted tubule, you've got a lot of reabsorption going on. About 65% of the filtrate is reabsorbed. The main thing that is reabsorbed, when we say reabsorbed, we're talking about it's going back into the blood vessels. So reabsorption means the filtrate, or the fluid that is in our capsular space in our tubules, is being reabsorbed into blood vessels. These tubules are surrounded by peritubular capillaries, and so they're constantly pulling solutes and water from the filtrate fluid. Secretion means stuff is leaving the capillaries and going into the tubulars for excretion in the urine. So reabsorption, so here the main thing is sodium. Sodium is being actively transported out of our filtrate, out of our fluid, and getting reabsorbed by the blood vessels. Because the sodium has a charge, chloride ions usually sort of bind to it and piggyback, because they are negative, so they are attracted to it. Glucose is another one that also piggybacks onto the sodium to return to the blood. We also have, water, lots of water. The water is going through osmosis. It's following its concentration gradient. So all of these leaving the filtrate creates a concentration gradient that the water wants to follow. And so it leaves the PCT and re-enters the blood as well. Our nephron loop, there's not quite as much reabsorption going on, but we do have more reabsorption. The main thing we have being reabsorbed in our nephron loop is our ions. So our sodium, our chloride, and we have our water, our H2O, that's in the Yeah, we've got lots of water going on over here. Our distal convoluted tubule, we have our DCT. We have, again, more ions, the sodium chloride, and more water. It acts here in the distal convoluted tubule as sort of the last chance for reabsorption to occur. Once it reaches the collecting duct, there's not much reabsorption of solutes going on. Primarily it's just water. And so the DCT sort of acts as a pH balance or an acid-base balance. So if the blood is basic, or acidic, the reabsorption of ions to counteract that will occur in the DCT. So we've got, again, more ions and more water. So that's sort of our tubular reabsorption. We do also have some, in the PCT, we do also have some nitrogenous waste. I'm just going to put N waste for nitrogenous waste. A lot of it is excreted in urine, but some of it our body does keep. But the secretion, so what is leaving the blood vessels and going into our tubular system, our filtrate, we have, drugs, contaminants. So I'm writing that in yellow to make you think of urine. We have drugs, contaminants, So when you take that aspirin, that's why it only lasts for contaminants for so many hours, because your body will excrete it in urine. And so then, So all of this is considered filtrate. Once you get to the collecting duct, it is considered urine. So here we have our urine. And pretty much the only thing being reabsorbed in our collecting duct is water. I hope that helps explain formation of urine. All right, thank you.